So page 301, go over some of those because Calc Chat didn't make sense.
Yeah.
Okay. Wonder if they just didn't show enough work, maybe? I don't know.
You skipped steps. For 23rd? Oh, wait. Yeah. Oh, yeah, for 23.
Okay, again, the better you are at derivatives and the more practice you get at antiderivatives, the easier this will become. You're not there yet, that's okay, but that's why we're practicing more today. So I can look at that and I think, wait a minute, I know what the derivative of 1 over t is. The derivative of 1 over t is negative 1 t to the negative 2, 1 over t squared. And so when I see 1 over t and 1 over t squared, I know that if I let all of this be u, right, because the 1's not really going to do anything, 1 plus 1 over t, or 1 plus t to the negative 1 if you want to write it as an exponent, then du would be, especially looking at this one, this piece of it, negative 1 t to the negative 2, or negative 1 over t squared dt, which is almost what we have. We need a negative in there, but that's an easy fix. So the antiderivative of u cubed du. Again, I can do that fast because I knew what to pick for u. But that's the key step, is being able to identify u so that du shows up. And again, the better you know your derivatives and the more practice you get at this, the quicker you can do these. So that would be 1/4 u to the 4th. Oh, negative 1/4. U was 1 plus 1 over t to the 4th. And don't forget the plus c. Is that better than Calc Chat? Not really. I'm taking the antiderivative, up the power, divided by the new power. (27) dy dx equals, so let's remove the dx over, so did a step on the fly there, moving the dx over. Integrate both sides. The integral of 1 dy is just y. And then now we're to the heart of the problem, integrating the rest of that. Integrating 4x, I can do that. So x squared over 2. But the rest of that is the tricky part. Maybe I should show my work here a little bit more. So I integrated the first one because that was easy, but now I've got to think about u substitution for that second piece. Emma, did you ask for this one? Mm-hmm. Did you have a good idea or a guess for what u should be or could be? Let's see. Anybody? Andrew? You said square root of 16 minus x squared? If we do that, then we get 1/2 16 minus x squared to the negative 1/2 times negative 2x. That's a lot going on there. I think just 16 minus x squared. You actually could maybe do this. I wouldn't recommend it, but it could be done. that way. I think the easier way is to let u be 16 minus x squared. Du then is negative 2x dx, which is close to what we have in the top. So how do you want to, there's multiple options here. How do you want to fix that 4 and make it a 2?
Multiply by negative 1/2.
Okay. And so I like that answer. But if that's all I do, that's not legal.
You put a 2 up front.
Negative 2 out front.
Right.
So now, again, the reason we did that was to make all of this match du. And the only thing we're allowed to do to force a match like that is multiply by a constant. You can't throw an extra x in there. You can't throw a sine or a square root or a natural log or anything crazier than just a constant. Constant's okay. Anything more than that, not okay. So that's u to the negative 1/2. And then all that stuff in the top is just du. And I guess I need to be careful. I don't want to forget the rest of this problem. So increase the power by 1. Divide by the new power. So divide by 1/2 is multiplied by 2. And I'm going to get lazy and not put the plus c on until the end. Yeah, and that's one that maybe CalcChat may do something crazy with. Who knows? They like to do algebra at the end of problems that's unnecessary. It's like nobody told CalcChat about the safe stop. They'd like to go way past that.
Was 29 included in the every other odd? Because from 7...
Right, 29 should not have been included in the every other odd, yes. Someone later in the day figured that out, like, wait a minute, that doesn't land on 29. Like, you're right.
Maybe 39 or 41. Oh, yep.
Yes. Oh yeah, 39 is interesting because, well, do you know why 39 is interesting? What's that? It could go either way. That's exactly right. Because if you pick u to be sine, the derivative of sine is cosine. So that's there. If you pick u to be cosine, the derivative of cosine is sine. So you can do it either way. Although, yeah, you're right. If you pick u to be cosine, du is negative sine. And maybe for that reason, it's maybe easier to pick u to be, what do you think would be the better choice? Sine. Because then we don't have any negatives to worry about. So derivative of sine is cosine, although that's not all. You need to multiply it by 2 because of the chain rule. So I need a 2 on there to make that work, but then a 1/2 to keep it legal. So 2 cosine 2x dx. Oh, that's du. Sine of 2x is u. So increase the power by 1, divide by the new power. So 1/4 sine of 2x squared plus c. Surely somebody wants to ask the question that's lingering out there. No, the question about 39. You said we could do it either way. If we did it the other way, we end up with, it'd be a negative, but negative 1/4 cosine of 2x squared plus c. So how is it that those could be equal to each other?
You actually not write the integral sign.
So the integral sign belongs there, but then I use it so it doesn't belong here.
But then why do you like 1/4 in the next one?
Because the integral of u is u squared over 2,
Okay.
and then I combine those twos. But if we did it the other way, if we said u equals cosine 2x, we land this place. And so somehow these two things are supposed to be equal to each other. It's definitely related to that negative. Good old sine squared plus cosine squared equals 1. So that means that sine squared equals 1 minus cosine squared. So if we replace sine squared with 1 minus cosine squared, there's where we get the negative cosine. And the plus c at the end takes care of the 1. So that's a good question. So my answer would be this, but an equally acceptable answer would be that. And then number 41. Cosecant squared over cotangent cubed. Yuck. Let's see. Just trying to remember both of these here. Derivative of cosecant is cosecant cotangent. Negative cosecant cotangent. Derivative of cotangent is, do you remember the derivative of cotangent? Back up, do you remember the derivative of tangent? Tangent is secant squared, so cotangent is negative cosecant squared. Does that provide a hint as to what u should be? It should. U should be cotangent because then we'll get cosecant squared. And we can handle the cube as part of the integration. Yeah, if we make u be cotangent cubed, then du is going to be a mess. So that'd be too much. Let's let u be cotangent of x. Du is negative cosecant squared of x. That's an easy fix, the negatives. So all of the top is du, negative antiderivative of 1 over u cubed. And I wrote it like that intentionally, although most people can't integrate when it's written like that, because they're going to mess up how do you add 1 to that exponent. It'd be much better to take the time to write it as u to the negative 3. Now we can add 1 to the exponent. What's negative 3 plus 1? Negative 2. So u to the negative 2 divided by the new exponent with the negative out front. So positive 1/2. And then that u, I'm going to put it back in the bottom. U was cotangent. Cotangent squared x plus c. So kind of a tricky one, but when I saw all those cosecants and cotangents, like I don't have those memorized off the top of my head so well that I immediately recognize which one to do. That's one where I legitimately needed to write those down to figure out what makes good sense for a u.